Hi, I'm Kathy Stark. This lesson is about linear functions. We look at how to graph linear functions and some properties associated with them. To begin with, we're going to define a linear function. A linear function is a function defined by f of x equals ax plus b, where a and b are real numbers. Here's some examples of linear functions. G of x equals 2x minus 3. H of t is 6 plus 1/2 t. G of p equals negative 3.76 p. The thing that makes these three linear functions is the power on the independent variable is 1. Notice that in g of x, the number 2 represents a, and negative 3 sits where the b would be. The word linear means line-like, which implies that the graph of a linear function is a line. In order to graph a line, we need 3 points. Let's try an example. What we're going to do is graph the following linear function by hand, and then we will support our answer with the calculator-generated graph. As we work this problem, we're going to give the x-intercept, y-intercept, domain, and range of the function. As I mentioned, we need 3 points in order to graph a linear function. We can choose any values we like. When the coefficient of x is a fraction, it's to our advantage to choose numbers that are divisible by the denominator of the fraction. Let's fill out the following table, first using 0 for x, then 10 for x, and then we'll use 0 for f of x, which corresponds to y, and solve for x. Starting with 0, I want to know what is f of 0. I substitute 0 for x and simplify. F of 0 is 0 plus 2, which is 2. We can fill 2 into our table. Now let's use 10 for x. I need to know what is f of 10. Substitute 10 for x. To simplify, remember that when you multiply fractions, to consider 10 to be 10 over 1, multiply numerators and denominators. This is negative 20 fifths plus 2, which is negative 4 plus 2, or negative 2. We can fill negative 2 into our table. Now what we're going to do is put 0 for f of x and find the x that corresponds to that. Here we go. 0 is negative 2 fifths x plus 2. Let's begin by subtracting 2 from both sides of the equation, in which case we get negative 2 equals negative 2 fifths x. Since I want x, I'm going to multiply each side of the equation by the reciprocal of negative 2 fifths, which is negative 5 over 2. What that leaves on the right-hand side is x. On the left, I need to figure out negative 5 over 2 times negative 2, which I will put over 1. This simplifies to 10 over 2, or 5. So when y, or f of x, is 0, x is 5. Now we have 3 ordered pairs that we can plot in a coordinate system and connect to get the graph of a line. Here's our coordinate system. We need to plot the points 0, 2, 10, negative 2, and 5, 0. Starting with 0, 2, then positive 10, negative 2, and then the third ordered pair is 5 in the x direction, 0 in the y direction. Connecting these, we end up with the graph of our line. I also want to point out the x-intercept is 5, the y-intercept is positive 2. The domain is all the x's that this line covers from left to right, or all real numbers. The range is all the y's this line covers from bottom to top, or all real numbers. Let's support our answer with a graphing calculator graph. What we're going to do is enter the function negative 2 fifths x plus 2. Remember that when you enter a fractional coefficient, that it itself needs to be in parentheses, times x plus 2. For this particular line, I'm going to zoom standard and take a look at the graph. This is the graph we found by hand. Notice that the y-intercept is 2, the x-intercept is 5, and the domain and range are both all real numbers. Now it's your turn to try a problem. Stop the tape and graph the following linear function by hand. Try to support your answer with the graphing calculator and find the x-intercept, y-intercept, domain, and range. Let's see how you did. In order to graph the function by hand, we need to find 3 points that satisfy the equation. These are the 3 I've chosen. Starting with x equal to 0, I need to find f of 0. Replacing 0 with x with 0, what we need to find or simplify to get 0 minus 6 or negative 6. Negative 6 goes in the table. To fill in the next spot in the table, I'm going to put 0 for y, or f of x. 0 equals 3x minus 6. Add 6 to both sides to get 6 is equal to 3x. And now divide by 3 to get x is equal to 2. We can put that in our table. The last thing I'm going to use is negative 2 for x. I need to find f of negative 2. That's 3 times negative 2 minus 6, which is negative 6 minus 6, which is negative 12. And I can put negative 12 in the table. I'm ready to plot these ordered pairs in a coordinate system. Making note of them again, they are 0, negative 6, 2, 0, and negative 2, negative 12. Plotting those, I have 0, negative 6. The next one is 2, 0, and the third is negative 2, negative 12. Negative 2, negative 12 is slightly off our grid, but would be approximately there. Drawing a line through these, I get roughly the graph of that line. Notice that the x-intercept is 2, the y-intercept is negative 6. The domain from left to right is all real numbers. The range from bottom to top is all real numbers. Let's move on to another concept involving lines, the slope. The slope is the numerical measure of the steepness of the line. In other words, its rise over its run. Here's the definition. The slope represented by the letter m of a line through the points x1, y1, and x2, y2 is y2 minus y1 over x2 minus x1. Let's try this out with an example. What we want to do is calculate the slope of the line that contains the points negative 2, 1, and 3, 2. Using the formula, we're going to subtract the y values. In this case, I choose to do 2 minus 1 over the difference in the x values, 3 minus negative 2. Simplifying, I get 1 over 5. The slope of the line that contains these 2 points is 1/5. Now in the formula, there's an x2 and a y2 and an x1 and a y1. I chose to use the second ordered pair as x2, y2 and the first as x1, y1. It doesn't make any difference as long as you're consistent, and whatever you use in the numerator, you use in the denominator. Now it's your turn to try a problem. Stop the tape and find the slope of the line that passes through the points 8, 4, and negative 1, negative 3. Then restart the tape and check your work. Let's see how you did. Here's the 2 ordered pairs. Let's subtract the y values in the order 4 minus negative 3 and put that over the difference in the x's, 8 minus negative 1. Simplifying, we get 7 over 9. The slope of the line is 7/9. Now we're going to move back to equations of lines and look at how to use the equation of a line to determine or find the line's slope. We defined a linear function as a function of the form f of x is ax plus b. The letter a, the coefficient of x, represents the slope of the line, and b represents the y-intercept of the line. Another version of this slope-intercept form is to write y for f of x and m for the slope, in which case m is the slope and b is the y-intercept. Let's use this form of the equation of a line and work through an example. Here's what we're going to do. Again, we will graph a linear function by hand, this time f of x equals 3x. We'll give the x-intercept, y-intercept, domain, and range, and in addition to that, we'll find the slope of the line. When we're done, we will support our answer with the graphing calculator. To graph by hand, we need 3 ordered pairs. Our line is the line f of x equals 3x. This time in our table, let's use 0 for x, then -1, then 2. Starting with 0, I need f of 0. 3 times 0 is 0. That goes in our table. Now I'm going to use -1 for x. F of -1 is 3 times -1, which is -3, which goes in our table. Now I'm going to use 2 for x. F of 2 is 3 times 2, which is the number 6. I have 3 ordered pairs to plot, and I can draw the equation of the line. I'll start with the ordered pair 0, 0. Then I'll plot -1, -3. And then I'll plot the ordered pair 2, 6. 2 in the x direction, 6 in the y direction. Connecting these, I can see the graph of the line. Notice that the x and y-intercept is 0. The domain is all real numbers. The range is all real numbers. And the slope of the line we can see in a couple of different ways. It's the measure of how the line rises over how it runs. In this case, it rises 6 units for 2 to the right. 6 over 2 is the number 3. That fits into the equation of the line. We see it as the coefficient of x. Let's check this, or support our answer, with the graphing calculator. In the y equals section of your graphing calculator, put in 3x. Again, just in the interest of time, let's zoom 6 and take a look at the graph. This graph looks just like what we drew by hand. This is the graph of the linear function 3x. Slope 3, x and y-intercept 0. We move on from here to the final item in this section, which is to look at 2 special cases of lines, horizontal lines and vertical lines. To begin with, horizontal lines have slope 0. They rise 0 units for any amount of run. Here's an example. Let's graph the line f of x equals -3 by hand. We'll give the x-intercept, y-intercept, domain, range, and slope. To graph this particular line, for any x value, the y-coordinate will always be -3. 3 ordered pairs might be anything with -3 as the y-coordinate. We'll use 1, -3, 0, -3, and -4, -3. These x's are chosen arbitrarily. Let's plot these and see what the graph looks like. We're going to start with +1, -3, then 0, -3, then -4, -3. Connecting these 3 ordered pairs, here's the graph of the line. The x-intercept does not exist. It never touches the x-axis. There is no x-intercept. The y-intercept is -3. The domain is all real numbers. The range is specifically only the number -3. And the slope of the line is 0. The line rises 0 units for any number of units to the right. From here we move on to the other special case, which is vertical lines. Vertical lines are lines that have undefined slope. With that in mind, let's look at an example. Again, we're going to graph a line. This time we're going to graph the line x equals 2 by hand. We're going to give the x-intercept, y-intercept, domain, range, and slope. For this line, x is fixed to be 2. To come up with 3 ordered pairs, we specifically use 2 for x, but can pick anything we want for y. Let's use 3, and then 0, and maybe -3 as 3 ordered pairs. We want to plot these in a coordinate system. I'm going to start by plotting the point 2, +3. My second ordered pair is 2, 0. 2 in the x direction, 0 in the y direction. And my third ordered pair is 2 in the x direction, -3 in the y direction. Connecting these 3, I get the graph of a vertical line. Its x-intercept is 2. It has no y-intercept. Its domain is only the x value 2. Its range is all real numbers, and its slope, we say, is undefined. It moves 0 units in the x direction for any number of units in the y direction. As a final concept involving slope, there is a way to use the slope of a line to come up with a graph without finding 3 ordered pairs. Let me illustrate that with an example. Here's what we'll do. We're going to sketch by hand the graph of the line that passes through the point 0, -4 and has slope 3/4. In a coordinate system, we'll begin by plotting the point 0, -4. This time I'm going to go ahead and draw the coordinate system. Here's my y-axis and my x-axis. I want to start by plotting the point 0, -4, and from there count out the slope. The slope is 3 units vertically for every 4 units to the right. 1, 2, 3, 4. I go up 3 units, to the right 4 units, and locate another point. Between these 2 points, I can draw the line. Let me draw it extending in the other direction. In conclusion, in this section, we've looked at the definition of a linear function, and we've used the concept of slope to draw the graphs of lines. We also defined horizontal lines, those with slope 0, and vertical lines, those with undefined slope. Be sure to practice many exercises from your textbook to learn these formulas and use them.